Now Ansys has the displacements at each node, and let's use that and get Ansys to calculate the deformed shape for the beam. So highlight solution in the tree and select deformation total, and that adds the total deformation object under solution in the tree. And to populate that, click on solve. And so what Ansys just did was use nodal displacements and calculate the deformed shape via interpolation. And there is no matrix inversion involved, so this is a quick calculation, relatively speaking. And by default, you may not have max selected, so I'll deselect that. So to match your view, and you can zoom in and out. So you may have rotation selected by default, and if you click in the graphics window and then use a middle mouse wheel, you can zoom in and out. Okay, and you can translate by selecting the pan icon and dragging the model. So by using a combination of zooming in and out with a middle mouse wheel and the pan plus drag, you can get a suitable view. In case your model gets, kind of rotated by chance, you can get back to the default view along the z-axis by clicking on the z-axis. Yeah. Okay, that's the default view. And I can go back to the previous view by clicking on previous view. So there are some handy tools available to manipulate the view. And it's also useful to, when looking at the deformed shape, to turn on the undeformed wireframe. So go over here and select Show Undeformed Wireframe. Okay, so that shows the undeformed model, and that way you can calculate, you can compare the undeformed and the deformed shapes. And using this, we can check if our deformed shape looks reasonable and honors the boundary conditions that we have applied. We have constrained this node or this vertex to not move in either direction, and it looks like it's doing so. I can confirm that by zooming in using the left mouse button and drawing a rectangle. Okay, so indeed this point stays fixed. Let me go back to the previous view and similarly I can check that this point is not moving, and that seems to be the case. So I'll go back to the previous view. Okay, so our displacement constraints are honored, and our downward force is somewhere over here, so the deformed shape looks reasonable. And because our force is offset to the right from the center, the deformed shape is also offset to the right rather than being symmetric. So that's also expected. So sanity checks seem to indicate that the deformed shape looks reasonable. Next, let's look at the value of the maximum deformation. So if you look at the scale here, the value of the maximum deformation is 0.0178 inches. And to see where that occurs, you can click on the max label here. So it occurs at that location, and 0.0178 inches is really small compared to the length of the beam, which is 100 inches. So in fact, what Ansys is doing is, in the graphics, in the display, it's scaling the deformation by this factor, which is 2800. So if I plotted the deformation to true scale, I won't see anything because the deformation is so tiny compared to the length. So let's go back to the the default scaling so that we can see the deformation. But keep in mind that, you know, this view is much magnified. The deformations are much magnified. And we can save this to a file. So click on this icon here and select image to file. And scroll to the appropriate folder and select, give it a suitable name. So let's say this 2D beam. And so you'll get a PNG file in whatever folder you saved it in. You can also animate the displacement. So by clicking on animate here, this is kind of cool to see, but one should keep in mind that all Ansys is doing is interpolating between the final state and the undeformed state. So it just has the final deformed configuration, and so the intermediate frames are just linear interpolations. So I can stop the animation and then I may have to drag the animation all the way to the right to see the deformed configuration. So we will next, you know, look at the we'll have to note this value of maximum displacement 0.0178, and we will calculate our normalized maximum displacement from that. So save the project. Before moving on to calculate the normalized maximum displacement.